Hi everyone, my name is Tiago Rodrigues, I'm an OutSystems architect, and this is my second video of a series of videos where I explore and experiment a lot of GenAI capabilities, features, and discoveries integrating with OutSystems. My first video In my first video, I talk about the concept of fine-tuning an AI module, and what were the advantages and how could we do it. And mostly, I also showed an application to convert documentation and knowledge into the structure necessary to do it. And today we are going to focus on a completely different thing. So today we are going to focus on multi-agent systems. And we will start by exploring with what an agent is. So the difference between an agent and a simple module, AI module. We are also going to do a quick pick on the OutSystems AI Agent Builder, mostly for you to see how can we configure the agents. Then we are going to go from a single agent to what is a multi-agent system, the advantage of it, when should we implement it, and how should we implement it. And for today, we are going to focus on a specific pattern. So there are a lot of design patterns we can implement when we are building a multi-agent system, and today we are going to focus on the orchestration pattern or the supervisor pattern. There are many names, I'm going to close this video showing to you a demo of an application, the one that you see here, where we use a multi-agent system to deal with a ticket resolution. Okay, so it's not a complete real situation. At least I wouldn't put an AI doing this sort of operations without a human in a loop, but for this demo purpose, we will do it. Okay, so let's get started. Okay, so let's start with the first topic. What is an agent? And to analyze this, let's go back a bit into a module, an AI module. What is an AI module? And these two topics are really controversial right now because there is a huge gray area today in the definitions of what is a module, when it stops being a module and becomes an agent, because there are a lot of modules in the market, the more recent ones that someone may say that they already behave like an agent and so on. So this is a very controversial area, and you guys, if you start seeing videos about it and learning about it, you will see that there is a very gray area on it. So for me, I will give a definition, and I will talk about what in my perspective should be the difference between a module and an agent. Okay, so let's check here some information. So for example, according to IBM, if we check here in this article, an AI model is a program that has been trained on the set of data to recognize certain patterns and make decisions. So a really important point here, and this is common in every module, is that each module was trained on specific data. Okay, so when the developers or the creators of the module, when they are creating the model, that is basically a set of code, of algorithms, neural networks. We can imagine layers and layers of neural networks inside of a module, and they use a lot of data to train those models, so it requires a lot of data. So we can say that a module is basically a program using AI capabilities like neural networks, trained with heavy sets of data to produce a certain result. Now, the tricky part here comes with the part of decisions. So a module, normally, if we look into, for example, the initial versions of ChatGPT, so GPT 2 or 3 or 3.5, those modules, they didn't have a lot of tools behind it. They were simply more like chatbots where you talk with them and they would reply to you. And in my opinion, that is a more raw definition of what is a module, because a module first is stateless. So what it means is that when you go to ChatGPT, not right now, but when you go to ChatGPT, initially you would go to him, you would give an input, press enter, he processes and he gives an output. Okay, so it's stateless. So it doesn't mean that ChatGPT has a life on his own, because every time you press enter, an instance of the module is created where you can interact with it, and you give an input, he runs, gives the output, and he dies, or the instance gets killed. So there is no life cycle of a module, okay? Or the life cycle is very short. And this is very important to consider, because when you look at it as something that is simply like a sort of a tool where you give an input and he gives you an output based on that, that's it. You can imagine that being very restricted to what we can do with it. It doesn't have sensors, it does not actuate reactively with a certain environment. So basically the module is more like the intelligent part of a system, okay? So in that way, I do like to compare it with us humans, because in a certain part, this is something that it becomes more easy for me to understand, is to try to compare it to humans. And for me, we can make a sort of an analogy with what you see here. So for me, a module, not in the complete 100% way, but a module represents a bit a brain, a stateless brain that is basically the intelligent part of a system, okay? So you can have different modules. You can have GPT-4 for text, you can have DALL-E for image, Mistral, DeepSeek. So there are a lot of modules, each one of them with unique characteristics of how they process the information and give the output, okay? So we can associate a bit of it like the different brains that exists. So most likely my brain, it will be different from Jimmy's brain, John's, even a dog brain or a monkey. So each animal has unique characteristics of a brain. Okay, so we can see the modules a bit like the different brains that exist. So we can have brains more trained for a specific action, brains more trained for another action. We can even have brains trained with more data and brains trained with less data. Okay, we also have this with people. Okay, there are people that have more deep knowledge of certain topics than others. So it's similar here. But a brain, it's just a brain. So we give inputs to a brain, he processes things and he gives outputs, and he does that in a very fast way. Of course, it's a bit different because brain has memory, so the weights inside of it, they do change with the usage. It's not a rigid module, and the modules are not trained unless we on purpose train them. But to simplify, let's consider this. So what is an agent? An agent is when we pick a brain and we put a person on it. Or basically we pick the brain and we put the brain in the person, not the opposite. So when you start having a person instead of just a brain, you start having a concept of an existence. So you start having someone that has a life, that has a name, that exists with purposes, has goals, has a job. So I do like to look at an agent in the same way of a person, because an agent is basically a system, a more complex system that uses a module the same way that a person uses a brain. So it uses the module to be the intelligent part of it, but it also gives additionally more capabilities to act on the environment. It has sensors, it has actuators, it can have memory. Of course, the brain has memory, but in here it's more like a long memory where you connect, for example, with a database to get information. He can go on the internet, so he can navigate to a lot of places. For example, if you search on the internet, there are a lot of videos about it. I do like this one. I'm going to put it so you can see here that, for example, an agent here has the capability to react upon an environment. So it has sensors. He can delegate tasks. Yeah, this is optional. This is optional depending on the goal we want to give. He can have some autonomy depending on how we define him. He can have memory, and he can also interact with tools. For example, access internet, do web research, call APIs, and for example run code. So this is normally an agent. So it's basically, as we were showing here, it's basically a module with a purpose of living, with ways to interact with the world. Okay, so he has hands, he has eyes, he has a mouth, he has a body, so he can interact with the environment. Okay, so now that we talk about the agents and the modules, and let me also just show you quickly that for example, if we go to AI Agent Foundry, you guys can see here in the module catalog, this is a small list of the amount of modules that exist in the world, and you guys can see here that they have different purposes, right? So their brains are trained for different purposes, for chat, for image, for I know that there is here anyone for film, for classification, and that's it. So there are different brains. Okay, so I think we are ready to go to the next part to see how can we configure agents using the AI Agent Builder. Okay, so what is OutSystems AI Agent Builder? So OutSystems released it in ODC only, so this is only available for ODC. If you guys want to do this in O11, it's also possible, but you have to build it on your own, the integrations. So basically, AI Agent Builder is an application where you can connect to the different modules that exists, that you configure, and you can create agents on top of it. Okay, so how does this work? So when we go to the AI Agent Builder, we have here my agents. Okay, so I have here a set of them created, but for us to have these agents, if you guys look here, we always need to have a module configured, because we remember an agent always has to have an LLM module inside of it. And how can we do this? In the configurations, when we are configuring, we can create here connections to existing modules. In this case, this TIAG test module, it comes from one module deployed here from GPT-4o. So you see here this module, I deployed the module here, and then I went to the configurations and I configure to create a connection with the Azure OpenAI. So after this, I have now a module connection here created, the Tiago test module. And this will be used, or this can be used in two ways. Or you can simply call this module and you have service actions specifically to call this module, or you can create an agent on top of this module. Okay, so when you go here, you can select to create an agent, and you can select the module that you integrated. So in this case, Tiago test model. And then you have here a set of instructions that you can configure on the agent. For example, you can give him a role, a purpose. You can give them instructions of how to perform the tasks that he needs to perform. You can even add data. Okay, I will not go into this in this video, but you can read more about it. You can add data from OutSystems entities, and then you can also add here some configurations on the module, and you can test it. Okay, so the moment that we save an agent, you can put it a name and an ID, and this ID part, it will be very important because this is the way we can then call the service actions and specify the agent we want to call. Okay, so this is the way you define one agent, and you can then come here and you can see the different types of agents with all of them with their specific ID, so that they can be used. And how can we use them? We can use them in two ways. Or we can build chat bots on top of it, and of course that the chat bots are very attractive. Nowadays everyone has a chat bot on their website, but in my opinion these chat bots are not the unique use cases that we can have, and not even the most powerful ones. I do believe that the most powerful use cases is when we integrate that with our code. So you can see here AI Agent Builder, we have here this service action where we can call an agent using the service action, and you can see here we passed the agent ID. That was the ID I was talking about. We passed the historic chat messages for him to have context, remember what I said before, and then we can also specify the tools we want for him to execute. I will talk a bit more about tools when I show how to implement the multi-agent system here, and then we get the response and we can continue the code of what we were deploying. If it was an event, if it was a server action, we can continue doing what we were doing. So this is basically the definition of an agent and the different parts of it, and how can we use OutSystems AI Agent Builder to build our agents. So after having the agents built, you can start using them in the applications. Okay, and before we go to the application that I created, we just need to talk a bit about multi-agent systems, and that's what we are going to do next. So let's go. So what is a multi-agent system? Going back here again to IBM, they define the concept of a multi-agent system as a group of multiple agents working together, performing tasks to achieve a certain goal. Okay, so we talked about the modules, we talked about the agents, putting a body, a concept of a person on top of the module to create an agent. Now we are going to the second layer of collaboration, that is having AI agents working together to perform tasks. And to be honest, this is my favorite part of AI, because it's the moment where we start going really close into our human behavior in society. The way we work together, the way we divide the tasks, the way we break complex problems into smaller blocks, and we distribute them in a collaborative way, in a hierarchical way, depending on the tools. So this is a very good opportunity for everyone that has a mindset more close to processes instead of developing. This is a very good way to start increasing their knowledge going into multi-agent systems, because this will be the one of the critical paths in evolving AI in the next months and in the next years. This concept of multi-agent systems, they can work in a very different way. So there are different patterns and different designs where we can make agents work with each other, exactly in the way we do this in the real world. We can have patterns that are more collaborative. For example, when we are doing a research with a team, we can have each person of the team doing a research of a certain subtopic and then aggregating everything. We can have a more hierarchical design where we have a manager that picks a project and delegates different tasks into different team members, but then she also controls the outcome of those tasks. So there are different designs we can apply, right? And these different designs, personally, I do like to study them, the different architectures that we can have. And in this case, LangChain or LangGraph, they have really good videos showing of how we can implement the different designs here. And for example, you guys can see here, we may have the network, that was what I'm talking about, the collaborative, the networking, or it's called also the blackboard pattern. We can have the supervisor or the orchestrator, that's what we are going to talk today. And we can have also others, for example, more hierarchical, where we can have different levels of orchestrator or supervisors inside of it, or we can customize our own design pattern. Okay, but these are some known patterns. We can also have another one that more close to the pub-sub pattern, where basically it's a bit similar to the supervisor, but the supervisor doesn't act as a supervisor. He basically acts like a broadcaster. Whenever he receives an input, he distributes or he calls all agents with that attribute, and then each agent decides what to do, what the message. Or we can have, for example, simply the router. There is also the router pattern that is basically similar to supervisor, but the router node or the router agent, he does not receive back the results. He simply redirects messages to the different agents and they continue the process. So the router doesn't do anything after that. But we will today be focusing here on the supervisor, and we will see that more after. So there are here some questions we might ask. Okay, so how do we know when we need to have a multi-agent system or simply a single agent? If an agent already has tools and has intelligence to do that, why don't we simply use an agent and ask him to perform things? If you might recall a bit back what I was talking, if an agent resembles a bit a person, you might see that in our world, in our job, normally we don't have only a person to do complex tasks, because first, or the task requires different roles and different knowledges that that person doesn't have, and so we need to distribute the different roles to the different experts, or the task is so complex in terms of the chain of subtasks that are needed, that we need to break them. Even the person needs to break the job into different phases. Okay, for example, writing a master thesis. One person can write a master thesis, but most likely she will not do it that on a row completely without planning different phases, doing different jobs. Okay, so normally when you are doing a master thesis, you start investigating, you start collecting information, so that is a task per se. Then you start writing the master thesis, that's another task, and despite the fact that they are being done by the same person, they are very different. So we can also use the concept here of a multi-agent system to do that. And you may say, oh, but you are not using different agents, you are using the same agent. That's true, but we are breaking tasks, different tasks for the same agent in an organized way. So we can say that is a complex system. We can say it's a multi-agent system or not, but it's also a useful use case when considering it. So how should we think about it? When we are checking a task, a different requirement, so when we want AI to solve a problem, we can ask some questions to help us determine if it is a single agent or a multi-agent system. And you can ask something like, would this job that I want right now to be AI performing it, would this job be done only by one person or by a team? Because most likely, if it would be done by a team, it means that it would need to be also performed by a multi-agent system, because it's more easy for you to divide the tasks of the different team members into different agents, and it's more easy to replicate the way the team would work in the same way that the multi-agent system works between the agents. Then you can also ask, is the task a simple task or does it need to be decomposed? For example, the example I was giving about the master thesis, basically delivering a master thesis is a very complex task that can be decomposed in smaller tasks, and even those smaller tasks can be decomposed in even smaller tasks. So it's a perfect example of a task that would need to be decomposed, and in that case we can also look at it into a multi-agent system. And there is also here a question that I do believe it's important, because it might make us see a bit different the agents versus the persons. That is the fact, you might ask if the person that is performing a certain task, if that person has a multi-role mindset or not. For example, imagine that you have a team member or you have a project where you have the same person reading the requirements and specifying some requirements and developing. Okay, the same person is doing those two roles. Okay, you might say, oh, it's one person, so I just need a single agent. But that person is basically working, has two different persons, a business analyst and a developer. So the two mindsets are really different. The mindset that the person needs to have when she is analyzing the requirements, the user stories, and writing them, it's a completely different mindset than when the person is developing. And anyone that does that understands what I'm saying. So this basically means that if we are going to build an agents on top of it, and we want this to be really effective, it would be more handy if we also consider those two situations in a multi-agent system. Okay, having an agent more related with the development phase and another agent more related with the business analyst phase. Okay, so this helps knowing when we want to have, or when we should have, a single agent or a multi-agent system. Okay, so we talked here about the what is a multi-agent system, the different patterns. We are going to focus today more on the orchestrated pattern, and you can also find a lot of tools on the internet that helps build this concept of multi-agent system. So we have LangGraph, it's one of my favorites. You have Swarm, and that it's also sponsored by the OpenAI, or it belongs to the OpenAI. Then you have Crew AI, and from Microsoft you have AutoGen. Those four tools, they can be used to create multi-agent systems. Each one of them have their own way of doing. Some give more freedom than others, but those are some of the tools that exist on the market. Of course, there are others. But today, I want to show that it's also possible to use OutSystems as a tool to develop multi-agent systems. And this is what we are going to do next. Okay, so now let's check everything that was discussed here. Let's put into a real use case scenario using OutSystems. So what are we going to see today? A ticket management system. So the goal here is to build an OutSystems application where users can create tickets and report a malfunctioning, and in this case we will have a set of agents trying to solve the ticket, trying to detect what can be the cause and what needs to be done to correct the issues. And this will be done in this case, because we are testing this will be done completely by AI systems, and we are simulating here a lot of scenarios, so it's not a complete valid use case, but it shows how we can introduce already this concept into a valid use case. And in this case, we are talking about a company that has basically power plants where they generate electricity using generators, in this case Volvo generators, and they then have a set of power transformers, and they feed the grid with electricity. And so that they basically have a set of team and people maintaining this power generation plant. Yeah, I don't know if I'm saying correctly all the English jargon of what a power plant would have, but yeah, I'm just trying here to give a bit of similarity. So let's see what we want to build. So basically we have, as I said, we have a ticket that is submitted by the users, and it can be different tickets. There might be no electricity arriving a certain power transformer, or there can be an issue with the generators or with the grid. So there are here different tickets that can arrive, and when they arrive, we want the ticket manager, so we want an agent here, the ticket manager, to decide what should be the next action. And in this case, he can decide based on 5 outputs. So he can decide, for example, to call the network expert agent, and this network expert agent, he has all the knowledge and all the tools to measure and check the status of the network. He can call the Siemens expert, in this case Siemens being the expert more related with the electronic and electric equipments, power transformers, sensors, etc. Or he can call the Volvo expert, that it's basically the agent that has all the knowledge about the generators, the Volvo generators, that can help on that part. He can also, when he receives information from one of the 3 experts, he can also update the ticket info. So it's not the other agents that update, but it's the ticket manager that receives the information from them and then updates the ticket info. And he can also close the ticket when he considers that that everything was done, or everything is that was possibly to be done by the agents was done, and then the ticket can be closed. Okay, so important things here is that if you check the direction of the arrows, you may see that except for the closed ticket, all the actions go back again to the ticket manager. And this is an important pattern of the orchestrator or the supervisor, is that he calls a certain task of different agents, but then he receives the outcome of that task. So he can decide what is always the next action on each step that was given. And of course, when the ticket is closed, this process is closed, so it doesn't go back to him. Normally, one thing that we need to be careful with these patterns is that we need to create some guardrail mechanisms to ensure that this doesn't go in with infinite steps. Okay, so if the ticket manager doesn't get stuck into calling always the same agent and receiving the same result and being there stuck here. So normally we can put something like the max numbers of steps that it can go before close the ticket. There are different ways, but basically this is what we want to build. Okay, so let me help you defining how can we design better each one of the agents and each one of the steps. And I took this method from a course that I was in with regarding AI agents, and I will put the information on the description. But this part helps how can we define each step. Okay, so let's now take a look into another example. Imagine that we have here Anne that comes to Jimmy and say, "Hey Jimmy, you are the analyst, or are you the analyst? Okay, top. So I need your help gathering findings about company ABC Inc. For the report. So you have access to the SharePoint folder with all the documents, but feel free also to check it online, and you can create a document to put those findings and share with me." And yeah, we say, okay, sure, and I will start immediately. So basically, if we consider Jimmy to be an agent, what would be the characteristics of this agent? Okay, and for this I do like to build here this map that we see. This was the framework that I've learned in that course. So every time we want to define a task, we can, with a certain agent, we can check these four parts, let's say, of it. So first, the role, what we want, what role do we want to give to Jimmy in this case? Instructions, how should I perform the task? So this is where you define and detail the way you want the module to behave. Then the context, in this case the context is what we give to the agent for him to consider as an input to then generate a response. Okay, you can call it also an input. The multi-agents, there are some multi-agent system frameworks, for example Lang graph, that they also call the stage, but basically is the information that the module will have given to perform a certain or to give a certain result. And then finally the tools. So the tools is what capabilities do I have, and this is very important for this example. So in this situation, for example with Jimmy, right, so the fact that he needs to gather findings of the company ABC Inc., We can say that his role is to act as a business analyst. We can define the instructions as you need to access the SharePoint folder with all the documentation. You should also search online for relevant information, and you should also create a document and put findings, to put the findings and share it with them. And we could also add things like, for example, you should use formal language, you should be nice, you should be pragmatic. So you can also add instructions in terms of how the model should behave. Then we have the context, where we basically can put the summarized information that we check on the SharePoint files, or for example on the internet search, and also the content of the findings that we are giving, so that he can iterate on what he already found. Okay, but an important thing here to consider about the context is that context is a bit like short memory, like our short memory. So when you are giving a task to someone, for example to Jimmy, you cannot spend 30 minutes talking with him about everything that you need, because most likely after those 30 minutes he would not remember most of the situations. With the modules, it's more or less the same situation, because they do not behave exactly like us, but they do have a max amount of tokens that they can receive as an input. And what will happen is, for example, if they have a truncate strategy applied, what will happen is when it reaches the max amount of tokens that they can receive as an input, what will happen is that they will start truncating the information. So they will only start having the most important points considered, and they will forget things that are not so important, a bit like us. Okay, so for that reason, it's very important when we are building context that we simply do not give him enormous amounts of information, because he will not be able to consider all of them. So it's better if we have intelligent ways to summarize, to pick only the important things, and to give it as a context. Okay, so this would be the context. And then finally the tools. So you can see here that because of the instructions that he received from N, so he needs to have capabilities of getting SharePoint files from that folder. He needs to have the capacity to do online search. He also needs to be able to write in a document, create a document and write in a Word document. And he needs also to have the tool of share the document. Of course, that it seems a bit dummy, because we all know how to do this, and when we are doing this, we are not imagining that we are calling the function of getting a SharePoint file. We simply go to SharePoint and open a file and read. But for agents, it will make more sense to have these tools, because you will see that it makes more sense to divide them in different functionalities. Okay, so this was just an example for you guys to see, and feel free to use this every time you need to define an agent and the characteristics of it. This is a very handy way of doing it. So going back to our ticket management system. Okay, so let's focus here on the decide next action task. If we want to build something like that, what do we need to consider? Okay, we need to consider that this agent, he needs to act as a ticket manager, okay, so to decide the next actions, the next steps for the ticket resolution. And the instructions that I've put it here, feel free to consider on your side. But in here, I said that he needs to process the information based on the history of the ticket given. So I'm already saying that I'm giving the context of the previous history of the ticket, and decide what to do next. And then I give him here some instructions of how he needs to decide what's next. So You can request the analysis and information from domain experts, so from a network expert, from a Siemens if it is an electronic issue, or a Volvo expert if it is a mechanical issue. You can, or you should register any advancements in the ticket findings and the corrective actions when that information comes from the experts. And you should try to collect as much information as possible to solve the ticket. And finally, you must close the ticket when you get all the necessary information about the findings and the corrective actions. So it's a bit the instructions of how he should behave as a manager and the orchestrator. In terms of the context, basically, I'm giving him all the chat historic information. I know this might not be the most effective way, but just for the purpose of this demo, I'm giving him the full interaction and the previous steps that happen. And I also say to him, analyze the chat information and decide what to do next. And I give him again a short instruction of what he needs to do, just for it to be more on the top of his priorities, for him to not forget that he needs to perform this. And I also call here again important, call just one tool. This isn't working so well, but I will show it. But it's basically due to the limitation of the service action of calling an agent that you will see after. And for the tools, basically I'm giving him 3 tools. Call an expert, where he can call a specific expert, and he gives in the parameters what agent or what expert he wants to call. I'm giving him the tool also of updating a ticket info, and finally the tool of closing a ticket. So these are the 3 tools that he has. And now we are going to see how we can implement this, or how I implemented this in OutSystems and try the application. Ticket management system. So this is the application that I've built to test the multi-agent system, in this case the Orchestration Pattern. So basically, as I discussed before, it consists of a system where the users can create a ticket, and they can, by creating a ticket, basically it is up for the agents to decide what they need to do. So for example, let's look here in this ticket. So it says the title, no charge arrives in the power transformer 120C. By verifying the indicators on the entry of the power transformer 120C, I see that there are no measurement values on the multimeter and voltmeter. I think the voltmeter word doesn't exist, but that's okay, he understood. So by saving the ticket, as we are going to see after, basically he starts going on the flow that you saw before, and basically we will get something like this, where you will see that first we start by giving to the ticket manager something like, oh, here is the ticket, the description, and then the ticket manager decides what to do. In this case, you can see that he called the function, and I'm going to show after, but he called the function expert call, so he decided that there's a need to call an expert. The first parameter that I defined was to put some information for that expert. So please analyze the network connection and check if there is any disruption leading to the power transformer 120C. And on the second parameter, I configure him to call the network expert. He also, because there is the capability of the agents calling more than one tool, he also called the second one, in this case the Siemens. So because it's the second one and it's the current, he is currently only calling the last tool, and this is currently a limitation on the OutSystems service action, because when we integrate with the APIs from OpenAI, if we wouldn't do it if we would do it through the APIs and not through that service action, you would have the possibility to to give more options to the call, including the possibility of just calling one tool at a time or multiple. So in this case, even if I say to him that you only call one tool at a time, it's not enough, and he calls two of them. So it is a limitation, and I believe OutSystems will need to extend more the service actions capabilities. But right now, we assume that he only calls the last tool. So you can see that he called the expert Siemens. So the next step is Siemens expert. So in this case, he said that there was the inspection revealed that there is an issue. The root cause of problem was tracing to malfunctioning, blah blah blah. Corrective actions involved something. So he basically told again back to the ticket manager that there was indeed a malfunctioning, and it was restored, and now the system is operational. Because the system is now operational, so the ticket manager then decided to call the update ticket resolution with these arguments. The first argument was the issue, and the second argument was the actions. And after that, after updating the ticket resolution, then he decided to close the ticket. And we can see that in this case he only did like one coming and going, and we have here then the ticket information, the ticket resolution. So this is basically the flow. I think I have here another one. In this case, he called more. We can see that he called more agents. For example, there is here Volvo expert saying that there was no issue. He verified that there was an issue with a high temperature, but probably due to the malfunctioning not being completed. The ticket master decided also to call the Siemens expert 2 times, and then in the end he updated the ticket. But as you guys can see here, he repeated sometimes his outcome. So the system is not bulletproof, and you can see that, for example, in this case, after 12 interactions, I manually close the ticket. So you guys can see here that he didn't call for the close-up of the ticket. It was due to the size of the interactions that I created this limit of 12. So how does this work? So let's imagine that I want to add a ticket, and let me copy here something similar to what I already had before. So in this case, no charge arrives in power transformer 200C by verifying the indicators, blah blah blah, and I save. In this case, when I save, he automatically starts the analysis, and I can refresh some the information here. So I didn't do like an automatic refresh. It's a manual. So right now there is just one call, and we need to wait a bit. Okay, now we have more information. So the ticket manager decided to call the Siemens expert, and the Siemens expert then send it back to the ticket manager, and we may see that the ticket manager for some reason decides to get calling more times the Siemens. But we have here an update ticket resolution, and most likely this ended also with the 12 iterations with a maximum. So we have here 2 updates, but you can see how this works. So it's not bulletproof, it's bit far from it, but the goal is here. So what what does it happen under the hood? So if we go here to the application, so we have the screens, that part it's not a big deal. And then we have when we save, we have the ticket creator update, and inside of the ticket creator update you can see that I create a ticket, I create the first context, and then I call an event called process trigger. And in this event I have here on process triggered, we update the state of it, exactly, we put it in analysis, and we start by calling the orchestrator. And now this is basically, you guys will see that we have for each agent we have an event, and also for the close ticket and for the update. And if we go then inside of the orchestrator, you guys can see that I start by getting the context. So every time there is an interaction with an agent, I save the result in this table called agent context, where basically I say who was the sender of the message, if it was an assistant, which assistant, or a user. I put the name and the content. So whenever I call an agent, I send him the context. Here I impose the limit of the 12 that you guys saw. So if there are more than 12 interactions, he will close the ticket by limit. And now we add the context. I add an extra message asking him what I need him to do. So do you guys remember on the PowerPoint where I show you the context, what I was sending? This is exactly what I was sending. So I was sending all the context plus an additional instructions to make it more, for him to give more importance to this. And then I call the ticket manager. And you guys can see that when I call the ticket manager, I'm using this service action, right? So I'm passing the ticket manager ID, that was the agent that you guys saw on the Agent AI Builder. I pass the chat messages with the information, and then I indicate what functions can the agent fetch. So in this case, I'm giving him 3 functions. How do the functions work? OutSystems currently, and the AI Agent Builder, is a bit limited on that. And the reason is because OutSystems is a strongly typed or uses only strongly typed structures. And the problem with that is that the real functions, for example, used on OpenAI or others, they use a flexible protocol. So they use OpenAPI to refer to a function, and what basically they do is to put this into a JSON format. So you need to define the name of the function, you need to have a description basically saying when you want the agent to use this function, and then there are a list of parameters and also a place where you define the required parameters, so which ones are mandatory for the agent to use. And inside of the parameters, because OutSystems is strongly typed, currently they need to define this general behavior. So if you guys see, the name of the parameters are parameter 1, parameter 2, parameter 3, etc. Nevertheless, in a true way of defining functions, you should give the name of the parameter with what he is doing. For example, in the function of the calling an expert, I'm defining the parameter 1 has additional information for the agent, so I would call the parameter additional information, and the parameter 2 I'm calling the agent type, or which agent, so the Siemens, the Volvo, or the network. In this case I would call for example, the expert. And inside we can make a description saying this you should call, or you should put here the value of the agent you want to call, and you can define, OutSystems allows also to define the possible values that they can have. And for example, in here I use this to say which agent he should choose. Okay, so this is a workaround that OutSystems team found to use functions. I do believe that it has very big limitations, because you are basically giving to the model parameters with the name parameter 1, parameter 2, so it lacks context. Of course, we can put a description, but I think it will not give the same effective results if we would name the parameters with what they do. Yeah, I really wish, or I really think that OutSystems would improve a lot if they would find a way to not make the structures always strongly typed, or if there could be some flexibility for us to work with like a text field that we could put inside flexible JSONs. So yeah, that is another thing to talk about, but I think they would benefit a lot. So going back here, talking about the function. So the function, basically you guys can see that when I'm calling an agent, I say the tools that he can use, and you can see that we have here two outputs, one response and one tool selection. The response is basically when the tool is not, or basically is the way for the tool to give the output of what he have done. For example, write me an article on LinkedIn, and then he writes the article on LinkedIn, or he gives the article. The tool selection is basically the results in the case of he calling a tool. Do you guys remember when I showed the application here? You see this JSON? This is the tool response. So you guys can see that it has the name with the function that he called, and the arguments with the parameters, parameter 1 and parameter 2. And this is how we make the agents follow the rules of certain information flow, because most of the times we want them to analyze the information and decide the next step or not, and this is done using tools. Okay, so in this case, let's see what it goes. So we call the ticket manager and we say this is your context. Now you have a function called expert call, and you should call when there is an issue. When there is an issue with the network, and you only use parameter 1 to indicate what you need from the expert, and then I put here that parameter 1 indicate what actions do you need from the expert, parameter 2 indicate the expert that you need to call, and you guys can see here in the enumerator network, Siemens and Volvo. So this is one of the tools. Second tool, and we say also that the requirement parameter is parameter 1. This can be also fine-tuned. I could put it also to parameter 2, but for now it didn't seem to have any issue with it. Then the second tool is close ticket, and I say call this function when you consider that you have all the information and you can close the ticket. And then the third tool is, and you can see that this doesn't have any parameters because I don't need any parameter from the agent. And the third function is where I say for him to update the ticket resolution, and I say call this function when you received information from the agents and you need to update the ticket. And you can see here that it has two parameters, one to indicate the findings and the second one to indicate the corrective actions. So you guys can see here, this is basically when I call him, I define the tools that I want him to do. And then when I receive his response, I create a context, but this is then the place where the magic happens, because I say immediately, okay, was the function that you called the close ticket? If yes, then launch the close ticket event. If it is to update the ticket, then launch the event to update the ticket. If it is an expert call, go to the switch. If it's not an expert call, it means that he didn't call any tool. In this case, basically I call again him to see if on the second time if he can call a tool. Normally this it's not needed, because if you put it tools, he will, most of the times he will, or almost 100% of the time he will call a function. Then if it was indeed an expert call, then let's go to the switch where if the parameter tool equals network, call the network's expert. If it equals Siemens, call the Siemens. If it equals Volvo, call Volvo. And you guys can see here that I'm basically checking the parameter too. So this is the way the orchestrator works. So you can see that he always ends on calling another event. And let's imagine that all the Siemens, Volvo and network, they are exactly the same. So let me show one of them. So I also start by calling all the context, adding some more instructions, and then I call the network expert. And in this case, you guys can see that he doesn't have any function, so he is simply giving text. That's why you see here that whenever it's an expert, it's plain text. It's no JSON like the functions. So basically I'm calling, there is a response from him, I create the context of it, and then I call again the orchestrator. This is an important part. I never finish the event of one of the experts without calling the orchestrator, because it needs to be the orchestrator deciding if everything is okay to finalize the process. So basically, in the end of their action, we always call back the orchestrator. And when the orchestrator updates the ticket, so in here we are simply updating the ticket and then calling back again him, and then finally when it's ready to close, and this is the only event that it does not call back again to the orchestrator, we update the ticket status and we stop. So right here you guys see that there is an end, so we do not call any other event. And this is basically how we are implementing the orchestrator workflow. So you can see that the orchestrator or the ticket manager, he basically distributes the next action depending on what he thinks should be the next action based on this 5. So you can see here 1, 2, 3, 4, 5. It's the same that I showed before on the PowerPoint, and each one of them do what needs to be done and go back to the orchestrator again, unless it is the closed ticket. And a very important thing is that if you notice, all of them update, all of the events, these events update the context. And the reason for that is that when we go back to calling the orchestrator, he needs to have the most updated context so that he can know what to do next. If you guys won't save here the context, the result of the agents, he would get stuck in the same loop because he would not get any updates of the agents. So this is basically how I've implemented the orchestration pattern in a multi-agent system. Some important considerations here. For ODC, I used basically an event-driven architecture here, where events call other events. It has some advantages mostly in terms of the speed of development, because it's faster to implement like this, and it's already embedded with business use cases with what he wants to solve. But the downgrade is that you need to implement a sort of way for you to check the flows that happen. So in this case, I'm saving the context, and with the context, I store the name. So with the name, I know the order of which things happen. But if we go into more complex systems, this is very difficult to achieve. One of the possibilities that I'm going to explore in following videos is to use the workflow capabilities of ODC. So if we create generic actions to call agents by giving them a purpose, the functions and so on, and if we build them using the workflow studio in ODC, maybe we can have a way of designing more flexible multi-agent systems. But in this case, I wanted to start by using events and event-driven. So this is it. Hope you guys liked it. This was just one of the patterns, the architect patterns that exists, the workflow. There are others, and they will follow in other videos. Hope you guys liked it, and feel free to challenge me or to comment about how we can do different things here, or what could I do better in this system. Okay, thanks a lot, guys. Bye bye.